But thank you very much for your really deep interest in the issue, because this is the good start for solving this problem. We were lucky in Poland to solve it, but it doesn't solve it forever. Yes, we have to continue and practice and so on. So it's a constant effort, and I wish you all the best. And if our experience will help you in any way, then I will be only happy.
Hello, I'm happy and excited to talk to you today. Professor Zbignyev, Mrčíniak, a mathematician from the Versia University in Poland. And my name is Michal Ijelon. I'm a faculty member at the Faculty of Mathematics Education at the University of חיפה. And as part of the seminar today in the subject of mathematical literacy in middle school, we are interested in learning from you and from your huge experience. So let me start with the reform in Poland you were a part of. In the Pisa test in 2003, Poland has ranked below the OECD average in mathematics, and you decided to conduct a detailed study based on the results of the Polish students. What did you learn in your research?
We analyzed item by item and found out that our students are lacking the basic feature, namely that they can do quite well things that they have practiced at school, and they just even don't start on problems which they have never seen before.
As we know, Poland's results in the Pisa test have improved, and in 2018, Poland has ranked 10th in mathematics. What were the main points of the reform? And also, maybe if you can refer to how did you prepare the ground in terms of the school managers and, of course, especially the teachers and students and parents?
We had really to, first of all, to prepare example problems, so that to let them know what we mean by this reasoning and argumentation. You need teachers, accept general theories, but they want to know what to do in classroom every day. So we produced a few hundred of example items, which looked like not very difficult. You must know, it's not the issue that you do difficult stuff. It should be basic stuff, but the student has to think on his own how to do it. It's not just something which was already practiced and you have to repeat what you knew. And then, of course, many teachers did not believe students will be able to do that. So the decisive point were the first exams, where we put these items that they were not present in any books, just example items on the exam. And the students loved it. Really, they said, well, it was enough to think, and then you knew how to do it. Yes, it was a new thing, and that convinced the teachers that it's a safe way. And in fact, we got the confirmation in the Pisa results in 2012 that even the weakest students progressed in the reasoning items because they had the courage to start on it before. And that was what I observed in the Israeli results. There's a big fraction of missing items, which means students don't believe in themselves. They look at the item and then they move to another one. Don't put any effort to imagine how I could solve it because it was not in classroom.
Yeah, it's not in the habits of mind, maybe.
Yeah, it's you have to convince students that they can do anything if they try. Now, and that's a big gap between the situation when they have just 30 practice routines that they have just to follow in exams. That's a big difference.
So can I ask just one more question about the teachers? How exactly, how you worked with the teachers? Did you work with them on specific practices of teaching towards mathematical literacy?
No, it's, well, you see, when you give students problems, the basic obstacle in getting a success here is to give students time. That's a big issue because teachers always complain they don't have enough time. So most teachers would just show students how to solve a problem. And then the next one and the next one, they should try to do the same way. That's a wrong way. I mean, if a student doesn't try to do something which he or she doesn't know how to do, and then overcome the difficulty, that's a different person. I mean, they start believing in themselves, and because the exam situation is exactly like that a student is just with the problem, without teacher. So the teachers had to move to this way of teaching, because they knew for sure students will see some problem they have never seen in classroom, because the system is working like that. So they had to let them think on themselves, because otherwise there will be no success. This is accessible to weaker students on the condition that the problems you give them are not exceeding too much their possibilities. That's the role of a good teacher, to recognize what a kid can do and give to him something more difficult, but only a little, so that a success comes. And then you can go. And our results show it's possible. The whole population has progressed.
So you are talking about giving the students a feeling of success, but also, of course, challenge them all the time.
It is very important in teaching mathematics to wake positive emotions. Mathematics without positive emotions is just a torture, because it's really doesn't forgive any mistake. Yes, you can't hide. You cannot, when in language you can say it someone differently, everybody understands you, it's okay. In mathematics, one small error kills the solution. So it is important that you have a positive attitude towards your work. Yes, that you like to do it. You have to, teachers have to create this emotional positive situation. It's very difficult because there are many distractions in today's world.
You recently performed with two other researchers an analysis of the achievement of Israeli students in Pisa. What are the most prominent findings relating to Israeli students' achievements?
I think just in short words, Israeli students are quite good in formal mathematics. Then the PISA deals with the so-called modeling cycle, when you have to formulate something mathematically, then employ mathematics, and then interpret the results. The middle stage, which is pure mathematics, they do quite well. But when it comes, but the difficulty is in the first phase, when you have to look at an unknown situation and try to turn it into mathematics. There's a problem. And there's less problem when it deals with quantities, with numbers, even with chances. There's a bigger problem when it comes to geometry, because geometry is harder to turn into algorithms. So teachers are not probably so willing to put a lot of attention to that. Because of that, the geometry problems are also the most difficult ones globally for the students. But if you aim to improve the results and increase the fraction of students who are at the top levels, geometry is the right way. I mean, put more geometry, and then you will get more students at levels 5 and 6.
Can you be maybe more specific? Do you have some ideas of how to do it, or what kinds of geometry?
Well, of course, in every country, there's a standard of teaching geometry. I am not meaning any revolution, but I mean questions which students really have to have an idea. For example, I give you maybe one or two examples. From our exam from middle school, you take a square, the size of one side is 1 meter, and divide it into small squares of 1 centimeter side, and then put them one after another. How long it will be? Yes, that's a question that you don't see in textbooks, and the student has to figure out how to calculate it. But that's an intriguing question. The student starts doing this because, after all, he's interested. Would be a 1 kilometer or 10 meters or whatever. And you think. Another example, which we gave on one of the first exams, introducing this new idea. You take a cube and you cut out the 8 corners, small cubic corners. What is the surface area of this body without these corners? And I remember the internet page of the Central Examination Commission where students are writing, oh my God, it was enough to see that it is the same, because the insides of these small cubes are the same as the outside. And that was a perfect solution for full score. Some of them were calculating quite crazy and got exactly the same answer. And only then you realize it was enough to think. You didn't have to calculate. This is the kind of problems that you don't see in textbooks, but students are ready to do that. So this is the kind of geometry I mean, not just calculate the volume of a cylinder or something. That's routine. This is done now by calculators. So why to waste a lot of time? Of course, students have to know how to do it, but that's not the part of mathematics that's most important in today's world.
I read that you claim that it is easier to improve the achievement of students with low achievements. Can you explain it, please?
That's for simple statistical reasons. I mean, there are more underachievers than the high achievers. So when you try to do something with this big group, then even if it happens with a small fraction, it's still a lot. So, and the second reason is that you don't need much to improve the results because, and I have to admit that the results of Pisa globally are quite weak. I mean, the demand of Pisa is not very high. It's far below what usually people think that mathematics is about. This is the basic knowledge.
And if we're talking about promoting within the top 5-6 levels, can you summarize and say some things about how do you believe that students can be promoted within the 5-6 or even toward the levels 5-6?
Yes. So two advices. One, let the students think by themselves. So give them time to think, give them problems that will inspire them to that they will find emotionally interesting. And also tell the teachers that they cannot avoid that. Best way is to put it on exams.
Yeah. Okay. Thank you so much for the interview. It was very, very interesting. And I think I can say that I learned a lot. And thank you very much.
Thank you for the interview, for the kind invitation.